Welcome back. Let's go to solve this problem about units. You have 1,299 grams. And it say add 1,299 to 45.1 kilogram and express the answer in milligram. What the problem is trying to teach you is that when you are going to add something, you need to add in the same units. For example, you have 45.1 kilograms. So it will be 45.1 per 1 kilogram. So it will be 45.1 per, but 1 kilogram is 1,000 grams. So it will be 45,100 grams. So if you add to this amount the 1,299 grams, you have to express this amount in grams. So now you can add. So this is 46,399 grams if you make the sum. Now you convert to milligrams. It says convert to milligram. I leave you to convert to milligram by dividing the grams by 1,000. So you divide by 1,000. Okay, so you do it. Now let's go to do this problem. This problem is about, it say you have a vector. The vector is on the second quadrant, okay? It's on the second quadrant, the first, the second quadrants. The vector have a magnitude 5.5, okay? This is the magnitude, the length of the vector. But it's 5.5 in this direction. It makes an angle of 34 degrees with the y positive direction. It doesn't say y positive, but it's suppose that it's the y positive. So what is the components ax and ay? What they are asking by the components? They are asking a bit about this. What is the ax here? And what is the ay here? What are the components? I see that ax is negative. I see that ay is positive. But what are? They give me the amount. So the way to do it, the straight way to do it, this problem is like this. The vector A is always the magnitude of A cosine of theta in the I direction plus the magnitude of A sine of theta in the J direction. But if applying this formula, if you want to find it to express a vector, you have to take into account that the angle is here is this angle. So this angle is not the 34. This angle is 90 plus 34. So if I want to apply directly the equations, the A, like this, I will say that the A is the magnitude of A is 5.5. Cosine of theta, cosine of 124. Magnitude of A, 5.5, plus sine of 124. And the sum will say that there is an amount AX that this is happen to be negative. AX is negative because cosine of 124 is negative in the I direction, so is this vector, and you know how to sum vectors. This vector plus this vector is this vector. So plus magnitude of A, sine of 124 in the J direction. So the vector A is expressed, but I like that you train yourself to visualize the picture and to say like this. You will say like this. This is the other way to find the vector A. The vector A is made of two vectors. This vector plus this vector. The sum of the two vectors is the vector A. So let's go to find this vector. This vector have the magnitude 5.5 cosine of this angle. What is this angle? This angle is 90 minus 34. 90 minus 34 is 56. And this vector is going in the minus I direction. So I will put the minus, I will put the I. So this is the vector A is the sum of two vectors. This one, and now I have to sum this one. This one, what is the magnitude of this one? Well, the magnitude of this one is 5.5 sine of 56. In what direction? Going up, in the j direction. So this expression for A and this expression for A, you can use your calculator, is the same thing because cosine of 124 is minus cosine of 56. And sine of 124 is the same that sine of 56. So this expression and this expression is the same one. What's the difference here? The difference here is that when you do it in this way, you are visualizing the vector. You know that this is the vector that they are asking you the component. So you say this vector is the sum of this one plus this one. This one, what the magnitude of this one? 5.5 cosine of this angle. What is the magnitude of this one? 5.5 sine of this angle. This angle is 56. So the vector is the sum, this plus this. This is minus 5.5 cosine of 56 in the minus I direction, and the other one is 5.5 sine of 56 in the j direction. And the problem is done. Now let's go to do this problem. The problem says you have two vectors, the v and the c, and they are asking you by the magnitude of the difference of the two vectors, v minus c. So to find v minus c, we have to find first what is v, and later on what is c, and later on what is v minus c. V minus c is the vector that goes from c to v, so v minus c is this vector. This is the vector v minus c. Correct or no? Or this is the vector c minus v. What you say? Well, if you are not sure, you make the sum. This is the vector c. So the vector c plus the vector v minus c, this one, the one that goes from here to here, it will be v. It will be v. Let's go to sum. C plus v minus c. Oh, yes, it will be the v. It will cancel, it will be the v. So this is the vector v minus c. So they are asking me about the magnitude of this vector. The magnitude of the vector, the difference of v minus the magnitude of this vector. So we find the v, we find the c, and we make the difference. The v, I'm going to apply the same procedure that I have applied on the last problem. The v, I visualize it like the sum of two vectors. The v is one vector like this going in the minus j direction, and another vector going in the minus I direction, the first one, and this one in the minus j direction. So what happened? So the magnitude of v is 5.6. So it should be 5.6 cosine of 33. Cosine of 33. So this is this side in the minus I direction. And again, 5.6 sine of 33 in the minus j direction. So that's complete the vector v as the sum of this vector plus this vector. Okay, so I have the vector v expressed. If you don't want to express the vector like this, you can express it directly by finding this angle. You find this angle. The angle is not now 33, the angle is 180 plus 33, and you say that the vector v is the vector 5.6. I remember that any vector a can be expressed like the magnitude of a cosine of theta by I plus the magnitude of A sine of theta by j plus the magnitude of A sine of theta by j. So the vector V will be 5.6 cosine, but theta, remember, theta is this angle. So this angle is 180 plus 33, which is 2013. 213 in the I direction plus 5.6 sine of 213 in the j direction. And this vector V and this vector V is the same one, the same expression. But if you do it like this, you visualize the vector. So the vector C can be, you think about why I wrote this. You see that I wrote the J first and later on the I first. You need to reorder the vector C. You reorder. But I'm going to write the vector C directly, like using this standard form for the vector. The vector C is 4.8 cosine of how much? This angle. This angle is 270 plus 22, 292. 292 in the I direction plus 4.8 sine of 292 in the j direction. So I have the vector V, I have the vector C. How I will find the vector V minus C? V minus C will be the vector that goes from the head of C to the head of B. Okay, let's go to find V minus C. V minus C will be component of B minus component X component of V minus X component of C. 5.6 cosine 215 minus 4.8 cosine of 292 in the I direction plus V minus C component of X of B, C is 5.6 sine of 213 minus 4.8 sine of 292 in the j direction. So I have a vector. And what is the magnitude of V minus C? The magnitude of any vector is the component x square root of this, or the component x square of this amount, plus the component of this square. So this amount is square. So if this is total is 5, you would put 5 squared. If this is 3, you would put 3 squared. And you would find this the magnitude of V minus C, or the vector V minus C. So the magnitude of vector A, AXI plus AYJ, is Pythagoras theorem. This is the vector A. The magnitude is AX squared. The magnitude of the vector is square is AX squared plus AY squared. So it's Pythagoras theorem. So the magnitude of A is a square root of AX squared plus AY squared. So work this problem carefully and find the result. Here there is several options. Find the result. Let's go to the next one. So this one is just to practice again the same idea that we already practiced. So please do it yourself. So this problem says vector A is the magnitude of vector A is 6.8. If it's a vector position, means 6.8 meters. It's a vector velocity, it means 6.8 meters per second. Vector A lies in the second quadrant and forms an angle of 30 degrees with the y-axis. So it's this vector that has magnitude 6.8 and the angle here is 30 degrees. the component ax and ay are closer to what? Well, this is the vector A. This is ay, and this is ax. So the vector A is made of ax plus ay, this vector. Ax plus ay in the j direction is the vector A. The vector A is the vector ax negative in the I direction plus ay, in this case positive in the j direction. So I'd say find ax and ay. From the picture I can see that this length, the ay is the magnitude of A by the cosine of 30. In this case, is the cosine of 30 because the angle is here. If you want to put the angle here, this angle will be 60. Oh, now ax, ay will be also ay will be the magnitude of A by sine of 60 and is positive. Now if I stay with this situation with the 30 degrees here, the ax will be A magnitude of A by the sine of 30, because this part is the sine of 30, but it will be negative. So ax will be in this case, because the magnitude is 6.8, it will be 6.8 cosine of 30 for ay. And ax will be 6.8 minus 6.8 sine of 30. Perfect. Now it say, what is this data? What is this amount? If I do it with the triangle like this, with the angle of 60 degree here, 60 degree, I will say that the ay, this part, is the sine of 60, not 30. So ay, if I do it like this, would be 6.8 sine of 60, while ax will be 6.8 cosine of 60. This is the cosine, but it's negative because it's going in this direction. So what is the correct answer here? Well, make the calculation and find it. The other way to see this problem is to say, okay, A is the vector 6.8 cosine of theta in the I direction plus 6.8 sine of theta in the j direction. Wow, and what is theta? Theta is this angle. Oh, and this angle is 90 plus 30. 90 plus 30, 120. So the vector A will be 6.8 cosine of 120 in the I direction plus 6.8 sine of 120 in the j direction. So this is the ay, and this is the ax. All the ax and all the ay that I have deal here, this ay is the same that this ay. This ax is the same that this ax. All of them, they are the same. So please try to remake the problem and choose where is the ax. For sure, the valid one, this one cannot be valid because ax is negative. So it could be any of these two, could be 5.9. So I can say that the valid one will be maybe, well, should be the ax should be negative and the ay should be positive. This is only the two options. These are the two options. So which one is the real one? Here, make ay 6.8 sine of 60 and see if it's 3.4 or 5.9. Okay, whatever you do, you have to see this in different ways. In whatever you do, try to find the correct answer. Okay, let's go to solve this problem. This problem says like this. An airplane undergoes the following displacement. So he starts from the 0, 0. The first displacement is to go 59 kilometers in the direction 30 degrees. I interpret this 30 degree east of north. So east is this direction to the north. So I interpret like this, 30 degree. So this is 59 kilometers going 30 degree to the east, going to the north. Later on, he does 58 kilometers going to the south. So this is this direction. And finally, he goes 100 kilometers, 30 degrees north of the west. So the north is this direction. 30 degree to the west, I interpret that this is the 30 degree to the west. I interpret that this is 100 kilometers. So I have three vectors. The first vector, the first displacement is this one. The second displacement is this one. And the third displacement is this one, but if I want to sum, I need to put this displacement, the third one, on the head of the last one to produce the sum. If I do it, it will be here. R1, R2, 58 kilometers, and R3 is 100 kilometers going 30 degrees to the north. So this is 30 degrees, correct? Also 30 degrees, because this is 30 degrees with this direction, so this is 30 degrees also. Okay, so how to do this problem? We have three vectors, and we have to make the sum. When we have three vectors, R1, R2, and R3, how do we do the sum? S. Well, we join the tail of the first with the head of the last one. So this is the sum. So we have to join the tail of the first one with the head of the last one, of R3. So R1, R2, and R3. I didn't draw R3 correctly. I should have drawn R3 from here, 100 kilometers in the 30 degree direction, this 30 degree direction, or this 30 degree direction. In this direction, let's go to make the picture, to make it clear. In this direction, 100 kilometers, so it will be more or less like this. So the sum, let me erase now this vector, let me erase this one, let me erase this one, let me see if I can erase only this one. I think I cannot erase this one. Okay, so the sum, so this is R3, okay, R3 is 100 kilometers in the 30 degree direction, in this 30 degree direction, in this direction. Okay, so the sum should be this vector. This is the sum from the tail of the first to the head of the last one. This is the vector that is the sum. And knowing the vector that is the sum, we will know what component have the sum, what is this amount. We will know what is this amount, the y component of the sum, the x component of the sum, and knowing this and knowing, knowing Pythagoras theorem, we will know this distance. This distance square will be this distance square plus this distance square. So let's go to find this magnitude and this magnitude to find the sum. This is the sum. Okay. So who is R1? R1 is this vector, R1. Who is R1? So I should erase the vector, but R1, I should draw here R1. R1 is the vector that has 59 kilometers in the 30-degree direction. So R1 is clearly the vector 59 cosine of 30 in the I direction plus 59 sine of 30 in the j direction. R1 is the sum of this vector plus this vector. This vector is 59 sine of 30 in the j direction. And this vector is 59 cosine of 30 in the I direction. So this is the vector R1. Who is the vector R2? The vector R2 is the vector that goes exactly to the south. So it's going in the minus j direction. So I made a mistake. Here is on the minus j direction. So the vector R2 is the vector 0i, because there is nothing in the I direction, is pure j direction, minus 58 kilometers in the j direction. So this is R2. Who is R3? R3 is this vector, the vector that has magnitude 100 kilometers and have 30 degree here. Oh, so this vector is the sum of this vector plus this vector. Oh, what is this vector? This vector is 100 cosine of 30 is not this vector. Oh, I made a mistake. Let's go to correct. Let's go to correct. I made a mistake. This is not minus 100. Okay, let me correct this vector. This vector, there are two ways of doing this vector. The first way is the direct way. The direct way will say 100 cosine of all this angle through the positive x direction. So this is 90 and this is 30. I'm sorry that I draw the sum, so I'm looking now for the vector R2. So let's go to draw the vector R2 here, so you will see clearly. The vector R2 is this vector. This vector is the vector R2. It's the vector that has 100 kilometers, and this angle is 30 degrees. So this angle is 90 plus 130, so it's 120. So the first way to draw, wow, I draw a different, okay, I draw a different angle. So this is the vector R3. So the vector R3 is cosine of 210 in the I direction plus 100 sine of 210 in the I direction. This is the straightforward way to write a vector. In the expression, in the standard way, magnitude of A, cosine of the angle with the x-axis in the I direction, plus magnitude of A, sine of alpha in the j direction. But I have said many times, it's better to visualize the vector. To visualize the vector, it means to to see what are the components of the vector. This is 100. This is 100, okay. 100 kilometers, 30 degrees. So this is 60. So this vector is made of two vectors, one going in this direction plus one going in this direction. So finding this one and finding this other one, I can find the sum. So the sum will reproduce this vector of 100 meters, 30 degrees. So what is the vector A? Well, I found the vector A. The vector A is 100. I found the vector R3. The vector R3, if I use the 100, will be 100 cosine of 120 I plus 100 sine of 110j. Okay, this is the vector A, but I want to write it visually. So I want to write the sum of this vector plus this vector. what is this amount? If this is 60, this is 100 cosine of 60. And this is 60, this amount is 100 sine of 60. So the vector A is 100 cosine of 60 in the I direction, so all this amount, but all this amount goes in the minus I direction. I is going in this direction, so it should be this. Now, plus this one is going in the J direction. This one is going in the J direction, to the north, plus 100 sine 60 in the J direction. So this is the vector that is exactly the same one that this vector, the same one, because cosine of 120 is minus cosine of 60. Wow. So I have the three vectors. Now I have to do the sum. Let's go to do the sum. And because I made a mistake here, let me erase here everything. Let me erase. So if I make the sum, and later on I see the components of the sum, and later on I apply Pythagoras theorem, I'm done. Let's go to erase this. Let's go to erase all this thing. Okay. So what is the sum? The sum is obtained by summing the I component with the I component. So what is in the I component of the sum? I see this part, this 0, and this part. Of course, the 0 I will not put it. So it will be 59 cosine of 30 minus 100 cosine of 60. Okay, this is the I component. And what is the J component? The J component, what is going in the J direction? It's going 59 sine of 30. 59 sine of 30 is going 58 to the south, and also is going R3, that is 100 sine of 60. Sine of 60, 100 sine of 60 in the J direction. So I have the vector sum. I found the vector sum. So this vector sum have an X component and a Y component. So the problem is asking me what is the magnitude of the vector sum. So it's asking me what is this magnitude. This is the sum. Okay, this is the sum R1 plus R2 plus R3. This is the sum. It's asking me about the magnitude of the vector. I have the vector. This is the vector. You have to work a little bit cosine of 30 and make it a number, no? Okay, let's say that this number is S is after doing the calculation, let's say that this is 3i plus, well, let's go to put it like we see in the picture, is something negative minus 3i plus 4j. I see that the sum will be this structure. The sum is this vector, it will be something negative plus something positive. So what is the amount of what is this length? What is this length? Okay, so I will find the length using Pythagoras theorem. If this happen to be that is 3, that is not 3, I know, and this is happen to be 5, what is the magnitude of the vector? The magnitude of the vector is the square root of ax squared. The magnitude of A, or the sum, is ax squared plus ay squared. So in this case, the magnitude of S will be a square root of 3 squared minus 3 squared will be positive, plus 4 squared. And you calculate this quantity in your calculator, you calculate this quantity in your calculator, and the result you put it here and you compare with one of the results here. I don't know why they look very similar, but one of them is the correct answer. Okay.